So for this example here, we're told that f of x is a probability density function and it has the following rule. So f of x is a hybrid function where one branch is a multiplied by x squared plus 1, defined from 0 to 1, and then it's defined 0 as everywhere else. Now in this question, we're asked to determine what the value of a is. So straight away, whenever we see this question, the first thing we should think is what are the conditions for our function to be a probability density function? And the main one that's actually going to determine what a is the fact that the area underneath the graph has to be equal to 1 for a probability density function. And that's exactly what we'd say is our first step of working out. So we'd say the integral from negative infinity to infinity of f of x dx is equal to 1. Now in this specific case, we don't worry about negative infinity to infinity, we care more about this non-zero branch here. So we can say specifically for this question that the integral from 0 to 1 of a outside of x squared plus 1 dx is equal to 1. Now this is something that we can just solve on the calculator. I've pre-done that just to save a bit of time, and I essentially just wrote it in there. Integral of a multiplied by x squared plus 1 from 0 to 1 is equal to 4a on 3. So if I wanted to find the a value, I just make this equal to 1 and I solve for a. Or I could just do it manually if I wanted to, but just to confirm, it is 3/4. So a would be equal to 3/4 for this probability density function to be a probability density function. Now the next question is sketching a graph of f of x on this axis here. So what I need to do is sketch a multiplied by x squared plus 1, a being 3/4. I need to sketch that from 0 to 1, and then I also need to sketch 0 everywhere else. So if my rule, so y is equal to 3/4 x squared plus 1. I'm going to try and do this without the calculator. So if we wanted to expand this out, 3/4 x squared plus 3/4, the y-intercept and also the turning point, because we have no x translation, that's just going to be equal to 3/4. So I'm just going to start that up here. And just note that in the domain that it's given to us, we have x is less than or equal to 0. So I want to use a closed circle here to indicate that it's inclusive. And that's really important, as you'll see later on. Now, if I wanted to find the endpoint, x is equal to 1, I just substitute that in. So it would be 3/4 multiplied by 1 squared plus 1, 3/4 multiplied by 2 becomes 3/2. So I'm essentially just going to double my value. I'm actually going to move my stuff to the grid. Let me just rub out this dot here. Cool. So I'm just going to move that to this point there, just to make it extra clear. And then I'm going to move that here. Sweet. So this starting point here is going to be 0,3/4, and then this point here is going to be 1,3/2. So it's going to be a parabola with that as the flat point. Now, a lot of people would stop here. And it's a problem because, and that's the reason why I brought this question up, and that's why I'm doing it from scratch. It's because a lot of people forget this 0 otherwise, which is almost the most important part of this graph, because you have to define the x value everywhere as if, and it's like sketching a part of a graph without having all of the parts there. It's incomplete, and it doesn't force everywhere else to be 0, which is really important for a probability density function. So what we need to do is draw the y is equal to 0, which is just a line along the x-axis. So this point here will be hollow, and then you extend that along the x-axis with an arrow to indicate it goes forever, and then this point here would be hollow again, and then you go left towards negative infinity. So this coordinate here would be 0, 0, this coordinate here would be 1, 0, and this is your graph of f of x done. Now if we wanted to find the probability that x is greater than half, then we could just do this on the calculator. I'm not going to bother doing it by hand. So what we'd do is we'd have a lower bound of 1/2 and an upper bound of 1. A, we know now, is 3/4, so I'm just going to put that in. So 3/4 multiplied by x squared plus 1, and this will give me my probability of 19/32. So this would be my final answer for this question.